Okay, this lesson is 3.3 on force and motion. Basically, we are going through the three effects, three laws of Newton. So the first one, effects of a force. This one you have learned in lower sec, so we will not be covering. You can find that in page 55 of your textbook. The main focus is actually on the Newton's three laws. So Newton's first law, second law, and third law. You can find it from page 56 to 60, which will the main thing. So I'm going to take from page 60 key ideas from there to kind of illustrate the main things. Okay, so the first one is if you have an object and the force on the left and the right both have 3 newtons, what can you say about the resultant force, or how can you say about the forces? Firstly, you can say that the forces are balanced. So what does that mean? When forces are balanced, you can say that the resultant force is actually 0. Okay, there's no resultant force. And this has an interesting relationship with acceleration. So when there's no resultant force, acceleration is 0. There's no acceleration. So when there's no acceleration, there's 2 possibilities actually. So we will think that, when there's no acceleration, the object must be at rest. Well, yes, it's one possibility. Object can be at rest, that means there's no acceleration. However, there's another possibility where the object is at constant speed. So when it's at constant speed, it is also no acceleration. So let's give an example to see how does this work. So if I have an object here and a person is pushing, let's say a boy is pushing at 10 newtons, right? And then this object is moving at a constant speed of 2 meters per second. Okay, and then they ask you what is the frictional force. So how do I know what's the frictional force here? What's the size of the frictional force? Okay, so one thing is if I have constant speed, what does that imply? It means that my acceleration is 0. It means my resultant force is 0, which means my forces are balanced. So what does that mean? So if I have a force pushing forward at 10 newtons, and the resultant force must be 0, that means the frictional force backwards, the frictional force must be also 10. So that's why frictional force in this case is 10. Okay, so this is how you understand when the question is in balanced forces. The second situation when the forces are not balanced. So for example, you have 5 newtons here and 2 newtons here. So here in this case, we can say the forces are unbalanced. That means there's a resultant force. Okay, there is a resultant force. And what can you say? There is an acceleration. So now we know there's an acceleration. How do we calculate this acceleration? There is this formula that links these 3 together under Newton's second law. So F is equals to ma. Your F stands for force. The unit is Newton. M is mass. Unit in kg. Take note, you must always convert to kg. Acceleration. The unit is meter per second square. So let's give an example to see if you understand how this works. So if I have a box and it's 1 kg, my force here is 5 newton, my force here it is 2 newton. How do I find? The question asks you what is the acceleration. How do you solve this? So firstly, you need to find what's the resultant force. In this case, the resultant force will be 3 newtons to the right. Then from there, using the formula F equals ma, I've changed around. My resultant force is 3 newton. My mass is 1 kg. I get 3 meters per second square. So this is how you use this unbalanced force and the formula to actually find acceleration.